Hi there, welcome to this tutorial on C programming with puzzles. In this specific video, we will be looking at a lot of C program examples. We would be looking at 8 different programs. In this video, we would start off with writing a program for odd and even, and we would continue on writing a lot of programs like leap year, sum of n numbers, and a lot of other complex programs. All the code examples that we would use during this tutorial are in GitHub in the repository in 28 minutes C tutorial in beginners. You should find the link below the video in the description. And there is a lot of information in here about what are the online editors you can use to run C programs and how you can use Eclipse CDT, how you can install Eclipse CDT to run these programs. All the programs that we would use, starting from the basic ones we use in other tutorials, as well as the programs that we would write in this particular thing. So is number even, leap year, sum of first n numbers, and even numbers, prime numbers, number of digits in a number. All the programs are in GitHub. So if you are not able to follow the video and you need to copy from somewhere, then you can go to GitHub and get the code from there and try to understand it. Let's get started now. Until now, we got a lot of theory under our belt. From now on, we try and make use of all the things that we have learned and try programming with it and add more things to what we learned. So in this program, we want to write a simple function to find out if a number is odd or even. So let's say we want to find out if a number is even. So I want to create a function which returns true if it's even and false if it's not even. So basically, if I pass 2 to the function, it should return me true because it's even, right? But if I pass 3 to a function, it should return me false. That's the thing that we would be working on in this specific example. Let's start. So I want to create a function is even. So how do I define a function? So I want to call the name of the function is even, and to it, what do you want to find out if it's even or not? I want to find it an integer number. So I want to find out if an integer number is even or not. So I'll call it int number, and until now we have looked at only void methods. Is even, I would want it to return back a value saying is it even or not. In C language, there is no Boolean value. In normal programming, like for example, if I was doing this in Java, there is something called Boolean. So I would have typed in Boolean. So I would have said if it's even, I would say return true. So true would be returned back, or I can say return false, so that false would be returned back. But unfortunately, in C, there is nothing like a Boolean. So what we have to do with is int, a integer value. So a integer value 0 represents false. Anything else other than 0, that's anything non-zero, represents true. So whether it's 1, -1, -1000, whatever the value, it represents true. So what we want to do here is if it is even. So let's try and kind of write the logic of this function. Let's quickly look at it. So if even, return true. So return true. In C, it's not return true, right? I mean, we have to say return true. So I'll say anything non-zero is fine. So I'll go ahead and put 1. We know that if also has an else. So else, so if it's not even, else I can return, so that it would be returning 0 back, which is false. So this is some kind of the logic that I would want to write. And how do I call this function? I'll call it in a printf. Printf %d, comma, is even of, let's say I want to check whether 4 is even or not. So I'll say 4 is even. Next, I also want to check for 5 if it's even or not. 5, is it even or not? So that's basically what we would want to print in here. Let's see how we can do that. So the algorithm is quite simple, right? We looked at it already. So it's simple. If it's even, if number is even, then return 1. Return statement is used to return a value back. So when I say return 1, what happens is if this line is executed, this function returns 1 back to this. So this value become 1, and that is what would be printed in here. So if number is even, return 1, and else return 0. That's simply the logic that we wrote. How do we find out if something is even? How do I find out if 4 is even or not? In C, there is an operator called modulus. So modulus operator returns the remainder when something is divided by something. So x mod y returns what is the remainder when x is divided by y. For an even number, the logic I am going to use, one of the logics possible is, for an even number, when you do a 4 mod 2, it returns 0, because the remainder when divided by 2 is 0. The same thing, when I do a 5 mod 2, the remainder would be 1, because 5 when divided by 2 will leave a remainder 1. So I'll use that logic in here. So I would want to do number mod 2. If it's 0, again remember, this is not assignment, this is comparison. I want to do comparison. So I want to do a comparison of 5 mod 2 with 1. If 5 mod 2 is equal to 1, what does it say? 5 mod 2 is 5 divided by 2, remainder is 1, so it's 1. So if it's 1, then what it means is it's not a even number, it's odd number. The same thing, so number mod 2, if it's 0, so I get a value 4. 4 mod 2 is 0. That's right. So if 0, then I want to return 1, else return 0. So I think that kinds of works. So let's go ahead and run this program and see. There you go. You can see the fact that for 4, it's returning a 1 back. 1 is indicating that it's a even number, and for 5, it's returning 0 back. So I can even check for other numbers. Let's say I want to check for 1, is it even? And 2, is it even? Run as local C++ application. And 1 is not even, 2 is even. So that's great. That's perfect. The one more thing is, this would be kind of an exercise for you to try out. Remove the else and see if the output of the program changes. If you look at it in detail, you would see that it would not, because if this condition is true, then this gets executed. So it comes to here, this line. If I'm returning something back in the program, the execution ends right then and there. So even if I had some printf in here, it will not be executed at all, because when I execute a return statement, it goes back, the control goes back to main. So in is even, once this return 1 is executed, the control goes back to main. So the next statements, if you have any statements in here, those will not be executed at all. And that's the reason why. So if this statement is executed, nothing else after that is executed. So if this is true, this statement is executed, so nothing after that is executed. So when we come here, it means this condition is not true, so I can directly assume and return 0. I would really recommend you to play around with this kind of stuff until you understand it a lot. And I think you'd see a lot of real world programs using things like this. Let us now write a program to find out if a year is leap year or not. Logic to find out if something is a leap year or not is quite simple actually. In most of the cases, if something is divisible by 4, then it's a leap year, except for a few scenarios. Those scenarios come at the end of or at the beginning of every century. So it's specific to these kind of years: 1900, 2000, 2100, 2200. The thing is, in these kinds of years, only every 4th year is a leap year. So 2000 is a leap year. So the next 3 years are not leap years. I mean, next subsequent 3 values, 2100, 2200, 2300 are not leap years. But 2400 is a leap year. We want to write a program which returns 1 for a leap year and 0 for a non-leap year. How do we do that? The approach we take usually for trying to find out if something is a leap year or not is, what are we certain about? The numbers which we are definitely certain about logic is, we know that if something is divisible by 400, so 2400, 2000, These are divisible by 400, and once something is divisible by 400, we don't need to really check anything else. It's a leap year for sure. So that's a certain condition, and that's one of the things that we would start coding with first. So if year mod 400 is equal to 0, if year mod 400 is equal to 0, year when divided by 400 leaves a remainder 0, then it's certainly a leap year. So I can return a 1 back. So the code would come to line 8 only if it's not divisible by 400. As we discussed with the return statement earlier, if line 7 is executed, when line 6 is true. So year mod 400 is equal to 0. In that case, this line 7 is executed, and line 8 and subsequent things will never be executed at all. So I don't need to say else and write the conditions again. You can directly say if and write the program. If there's a return, then I don't really need to use a else if. It just makes the program structure difficult to read. I can directly say if. So let's now consider the next condition. If year mod 100 is equal to 0, that's a year is divisible by 100. So something is not divisible by 400, but it's divisible by 100. Then, so 1900 for example, divisible by 100 but not divisible by 400. In that kind of situation, it's not a leap year. 1900 is not a leap year. 2100, 2200, 2300 are not leap years. In all those conditions, this will not be true. So it will come here and this will be true. So I can be sure it's not a leap year. So we have eliminated all these conditions now. So it will never be any of these years. So the execution would never come to line 11 or line 12 if it's any of these years. For these years, we have already handled the logic in here. So the rest of the logic is very simple. So if year mod 4 is equal to 0, if year is divisible by 4, then return 1. Yes, it is even. It is a leap year. Otherwise, I can return a 0 back. The thing about this particular program is we need to order the conditions. The way we order the conditions is the most important part of this particular program. The fact that if year is 400, the code would never even come here means that this condition essentially is that it's year is not 400. Year is not divisible by 400 and year is divisible by 100. This particular condition, you can almost read it as if not of this and not of this, and this is true, because the code would never go to this condition if any of these two is true. And that's the fact we are using to write a very, very simple program. Now, if I run this program, you'd see that the output is correct. So 2000 is divisible by 400 but not divisible by 100, so it's a even year. Sorry, it's a leap year. And 1900 is not a leap year because it's divisible by 400. Sorry, it's not divisible by 400 but divisible by 100. 1904 is a leap year. It's divisible by 4 and it's not one of those 100 years. And 1901, it's not a leap year. If you are a first time student looking at programming for the first time, this is kind of a complex thing to understand. Leap years is one of the programs which I really had a difficult time when I started off with my programs at almost 15 years back or maybe 20 years back. I would recommend you to stop, look at this program in detail and understand it completely. So try and understand every line of this program, look at it and try and get a complete knowledge about it. I think programs like this are the stepping stones for your success as programmer. So try and spend some time around it and try and think about it, and good luck. Now, let's start with a simple program for a for loop. I want to find the sum of first n numbers. Quite simple, isn't it? What should we do? So basically, if I pass a number 5, then I would want the function to return the sum of numbers from 1 to 5. So it should return 1 plus 2 plus so on up to 5. So it should place 1, 2, 3, 4 and 5. So that's basically the thing which I would want to sum it up and return it back. If you are interested, go and try what that value should be. It's actually 15. So let's write a program to find the sum of first n numbers. So I've a basic skeleton here already. So it returns an integer back, it accepts an integer parameter, calculates sum up to is the name I gave it, or you could have called it sum of first n numbers, something of that kind. Calculate sum up to 5, calculate sum up to 10, and I'm printing those values out. So what should be the logic in here? So what should the for loop? So basically I would want to find from 1 to n. So I have to run the loop from 1 to n, and I would want to keep adding them up. Whenever we want to keep adding the number, so I want to first run the loop from 1 to n and then add. So 1 to n, it basically means, let's say I'm running it from 1 to 5. So I should run it for 1, 2, 3, 4, and 5. And then I should keep adding these things to somewhere. What is that something? So I add 1 to 2, I want to store the result temporarily. Then I would add 3, then I would add 4, then I would add 5. So I need a temporary variable to hold the result. And that temporary variable, I would call it as result, and I'll give it an initial value of 0. If I don't give an initial value, think what would happen. Once I have a loop, then I can do result is equal to result plus the index. And I can run the loop from 1 to n. So that's kind of the logic that we would want to write. So let's go ahead and write it. It's not really complex. So for initialization, int I is equal to, usually we initialize I to 0 in most of the programs, but here we want to run it from 1 to n. So I is equal to 1, I less than n. Is this right? Less than n? No, this is not right, because if n is 5, I would want to run the loop from 1 to 5. So it should be I less than equal to n, I plus. Now I have a loop I running from 1 up to n. So for I is equal to 1 to n, I have a loop running. That's very good. Now I would want to keep adding each value of I to the result. So result is equal to result plus I, and then I could return the result back. So return result. So how would this program work? First, let's say I pass in a value 3. I would be 1, result plus 1, the result will be 0, result plus 1, so result will have a value 1. Then I becomes 2, so to the already existing value in result, 2 would be added. And then I would be 3, and to the already existing value in result, 3 would be added. And this is how the sum of first n numbers is calculated. Let's now run this program and see what happens. There you go. Sum up to 5, 15, as we already discussed. Sum up to 10, 55. Is it right? There's a formula n into n plus 1 by 2, which you can use to calculate. Or you might take the hard approach, add numbers up to 10 and check whether it's 55. Okay, so the concept which we learned in here is kind of using a temporary variable, and we are running a loop, and to the temporary variable we keep adding every index in the loop. So I is the index we are using, so we keep adding the index, and thereby we keep summing it up, and by the end we find out what the sum of first n numbers is. That's how this program works. As an exercise, you can probably change this program to find the multiplication of the first n numbers. There would be a few unexpected results down there, but it would be great to figure them out. Good luck. We want to find the sum of first n even numbers and first sum of n odd numbers. I'll do the sum of even numbers and I will leave the odd numbers as an exercise. Right now what we have in here is a program to find the sum of first n numbers. I would want to modify this to find out the sum of first n even numbers. So calculate sum even numbers. I'll just rename the function. The program as it is returns the sum of first n numbers. I want to make it return the sum of first n odd numbers. Is there a easy modification that we can do? Actually, we can achieve the result in two ways. One is changing the loop to run from, think about it. Right now the loop runs from 1 to n. If I want to find the sum of first n even numbers. What do I want to run it from? Think about it. The other thing is I'm adding 1 to n in here. Is there a way I can make it so that I can add 2 into 1 to 2 into n? How can I do that? Think about it again. Okay, let's implement the easiest solution first. So this is calculating sum up to n numbers. To make it, I want to calculate sum up to the n even numbers. I can do something of this kind. The first even number is when I is 1, it will have 2. When I is 2, this will be 4. When I is 3, this will be 6. So on. So that's the first way. So now this program, what it does is first when I is 1, it would have 2. And then when I is 2, it adds in 4. When I is 3, it adds in 3 into 2, which is 6. And so on up to n. And thereby it calculates the sum of first n even numbers. Let's run this program and see if it works fine. There you go. It's printing the right values. 30 and 110 are right. You can go ahead and calculate them and see if it's proper or not. So that's one way of doing the sum of first n even numbers. Now, I want to change the loop. I don't want to run the loop from I is equal to 1 to n I plus plus, but I want to run the loop from 2 to 2 into n. So I want to run the loop from, let's say n is 5. So I want to run the loop from 2 to 10, but I only want to use values which are even. So I want to run the loop having values 2, 4, 6, 8 and 10. How do I do that? So I want I to be 2 first, 4 next, 6 next. How do I do that? So I can start with 2, and while I less than equal to, if you look at each one of these, 2, 4, 6, 8, they have a difference of 2. So it's not sufficient if I do I plus plus. Actually, I should do I plus 2. If I do I less than equal to n, and if n is 5, then the loop stops here, because 6 is greater than 5, the loop would terminate. So I should actually do less than equal to n star 2. And now it would run the loop from, so it will be 2 plus 2, 4, 6, 8, 10, and then it would print the sum of first 5 even numbers. Aha, let's check that out. Okay, there you go. Same result as previous, different logic. I would really recommend you to look at both the things that we discussed during this particular section. Let's now discuss about a program to print the divisors of a number. What do I mean? Let's say take 12. The divisors of 12 are 1, you would exclude it because 1 kind of divides everything. So 2 divides 12 without leaving a remainder. I mean, 12 is divisible by 2 without leaving a remainder. The other divisors are 3, I can think of 4, 6. These are the divisors of 12. So let's write a program to print all of them. How we do that? So obviously I have to run a loop from 1 to n. So and I would want to check if it's divisible by 12. If 12, or if the number n is divisible by that particular index, how do I find out? If it's 0. So if number mod index is equal to 0, then it's fine. So then I can print f %d comma that particular number. So I guess this is kind of the logic that we would want to write. So let's try and write that particular program down. For loop to run from 1 to n, I don't really want to run it from 1 to n. That's one thing. So I want to run it from 2 to n minus 1, because 1 and n would always divide the number. So if I pass in a 12, then 12 will always be divisible by 1, and 12 will be divisible by 12. I mean, I don't really need that information. So I would want to really run it from 2 to n minus 1. So I'll start with int I is equal to 2. I want to check every number up to n, so not including n. So I put I less than n. I want to check every number 2, 3, 4, 5. So it's just I plus plus. And if n mod index here I'm using is I. So if number when divided by I would be 2 first, 3, 4, 5, 6, n minus 1. So If it's 0, then it would print the index value, which is I. And I think that's it. Okay, there you go. That's a very quick program. Print the divisors of a particular number. Now, I would want to write a small program to find out if a number is prime or not. So let's take the previous program as the starting point, and I'll just quickly make modifications. I want to return if a number is prime or not. So I would say is prime, and this would return a 0 if it's not prime, 1 it's prime. So 1, 0 means not prime, 1 would mean it's a prime. And I'll change the printf also in here. So let's put a printf %d, write the program for doing that. How do you find if a number is prime or not? So the attempt is to write a quick readable program and not really a most efficient one. So let's look at it. So the logic would be something of this kind. So I have a number n, or I have number 12. I want to find out if it's a prime or not. One way I can do that is to start from 2. So if I divide by 1, then it would leave a remainder 0. So it's divisible. Anything is divisible by 1. So I wouldn't want to consider 1 at all. So I would start with 2, 3, 4, and so on up to 11, and try to divide 12 by these numbers. And if any of these numbers divide 12 without leaving a remainder, so that's basically if 12 is divisible by any of these numbers without leaving a remainder, then it's not a prime. I can be sure about it, right? So that's basically how I would want to do this. So in terms of the loop, I want to run it from I is equal to 2 and I less than n, because I don't want to divide 12 by 12 itself. It will anyway be divisible. And I plus plus. That's basically the thing. And if n mod I is equal to 0, so if n is divisible by I, so if n mod I is equal to 0, that means 12 is divisible by 2, or 12 is divisible by 3, 12 is divisible by 6 and 4. So for any of these conditions, n mod I is equal to 0. So the result, what it would be? The result will be, is it a prime? No. I would initialize int result is equal to 1. It is a prime. So I'm saying it is a prime, and dividing with all the numbers possible which are less than equal to that, which are less than that, and if it's divisible by any of them, I'm changing the result to 0, and at the end I would say return result. So let's see if this program works. Okay, so it's for 4 it's printing 0, and for 5 it's printing 1. So for 4 it's saying 4 is a prime. Let's add a /n to make the program. So for 4 it's not a prime, 5 is a prime. However, this program would return a wrong value if I pass in is prime of 1. I will leave that to you to address. See what you can do to address 1, because 1 is neither prime nor composite. So that would be a good thing to look into. And if you look at this particular program, it can also be improved a little bit. Instead of having a temporary variable and assigning the result in here, I can do something else as well. So, for example, 12. When I start with 2 and 12 is divisible by 2, as soon as I know that 12 is divisible by 2, I don't need to check if it's divisible by 3 and 4, because since 12 is divisible by 2, it's not prime. I know that right then and there. So instead of storing the value and returning it later, I know at this point itself, once it's divisible by any of the values, 2 to n, any of the values, then I can directly return a 0 back. So this would be much more efficient, because now I can return a value 0 back just after dividing by 2. If the input n is 12, it divides by 2, yes, return 0. Simple. You don't really need to check all the others afterwards. And if it is coming up to here, if it's coming to line 14, the execution, it means it ran this program from 2 to n without returning 0 at any time. That means the number which came in is not divisible by anything else, so it's a prime. So I'll go ahead and return a 1. Run as local C++ application, you would see that the output does not change. So that's the program to find if a number is prime or not. There are a few efficiencies that you can bring into this program, like when uh, you don't need to really check up to n. You can check up to n by 2. Those kind of things. But like effectively, this program works. So you can take those things as an exercise and try them out. Let's now write a program to find the number of digits in a number. What do I mean? Let's take a number 456. The number of digits in this is 3. The next example 24567. Number of digits in this, can you guess? Yeah, it's 5. Tricky thing in here is deciding the logic of how do you want to do that. So how do I want to do this particular thing? And that's the most trickiest part. Think about it and see if you can come up with any logic. I would really recommend you to pause the video, think about what kind of logic you would be able to come up for being able to do this. What we'll now continue with is one of the ways you can do this. I have a number 456. I want to find the number of digits in this. The way I can do that is, one of the things is I can divide the number by 10. So 456 divided by 10 is 45, right? I'm excluding 6, 45.6, but I don't really care about the decimal. So now I know it's one digit. I would keep a counter 1. So 45 divided by 10 is 4. I'll increment the counter to 2. 4 divided by 10 is 0. The counter now is 3. So 456 has 3 digits. Now let's see again. Let's take another number 2, 3, 4, 5, 6. Now increment the counter, divide by 10. 3, 4, 5. Increment the counter, divide by 10. 3, 4. Increment the counter, divide by 10. 3. Increment the counter, divide by 10. 0. And now it's 0, I stop. So that's basically how I can do that. That's one of the ways I can do that. As you can see, when I see a number, I cannot decide how many times I have to execute a loop. In these kind of situations, we go for a while loop. So while I want to actually use this n and divide by 10, right? I have to keep dividing it by 10. But I am in a good programming, you should never change the value of a parameter. So I'll have a temporary variable. So I'll say temp is equal to n. I want to keep doing this until the value of temp becomes 0. So while temp is not equal to 0, what do I want to do? So what I want to do is divide by 10. So first thing I want to do is increment the counter. So increment counter and divide by 10. And while temp is not equal to 0. So divide by 10, again check if it's 0. If it's not 0, increment counter, divide by 10, again increment counter, and so on. So I need a counter variable. So I'll have a counter in count. As usual with counters, I start with 0. So while temp is not equal to 0, I want to increment the counter. So count plus plus and divide the number by 10. Temp by 10. Is this sufficient? No, I need to assign the value back to temp. So temp by 10 would just return the value, but it will not assign it to temp. So temp is equal to temp by 10. So what happens? First time, let's say the value of n which is passed in is 345. So 345. So temp would have a value of 345. Count would have a value of 0. Temp 345 is not equal to 0. That's right. So count plus plus, count becomes 1. However, temp is equal to temp by 10. So 34 by 10, 34. Temp not equal to 0. Yes, still temp is not equal to 0. 34 is not equal to 0. Count plus plus, count becomes 2. Temp is equal to temp by 10. 34 becomes 34 by 10, 3. And temp not equal to 0. Yes, it's 3, so it's not 0. Count plus plus, 2 becomes 3. Temp is equal to temp by 10. 3 by 10 is 0 because we are ignoring the fraction part. 0. Temp is 0, so it goes out. I'm returning a 1 back, which is not what I want to return. I want to return the count back. That's it. That's quite simple, isn't it? This is the program which would help you to find the number of digits. I mean, this would work for positive numbers. Let's now run a local application. There you go. 456 has 3, 24567 has 5. You can write this program and try running it with other numbers and see if you have any problems with it. We have just written a program to find the number of digits in a number. So let's go ahead and now write a program to find the sum of digits of a number. So instead of number of digits, I want to find sum of digits. I think what you're guessing is right. Sum of digits is nothing but 4 plus 5 plus 6, 4 plus 5, 9, 9 plus 6, 15. And 2 plus 4, 6, 6 plus 5, 11, 11 plus 6, 17, plus 7, 24. Okay, that's exactly what we want to do during this particular program. So sum of digits is what I want to find out for n. So how do I do that? So the way we would do that, as you would know, is the same logic as number of digits. So 345, when I divide by 10, I would get 34. But I'm losing the value 5. To be able to do the sum of the digits, I need the value of 5 to be added, right? So 34, the remainder is 5. So when I divide by 10, the remainder is 5. I would take that. When I divide 34 by 10, it's 3. But to 5, I would add the remainder again. So it's 5 plus 4. And then I would have 0 here. And here I would have 5 plus 4 plus 3. That's kind of the logic I would want to implement. So what I would want is not count, but I would want sum. So I'll rename the variables first. So it should be sum. And it's not sufficient if I increment it, right? I want to find, so I want to divide 10 by 10 and get the remainder. The way I do that is temp mod 10. So temp is having the intermediate value, right? 345, 34, 3. Who has the value? Temp. I want to, before dividing it by 10. If I do it after dividing by 10, I'll lose the value. Before dividing by 10, I want to find the remainder, what it would leave when it's divided by 10. The way I do that is using the mod operator. So temp mod 10, this would return a value and I would want to add it to this sum. So sum is equal to sum plus that and sum. Let's quickly run this program and see if it works. Aha! 4, 5, 6, 15, 2, 4, 5, 6, 7 is 24. 6 plus 7, 13, 18, 24. That's right. So how does this program work? So let's talk about 345. So 345 comes in, temp is equal to n, 345, sum is 0, so 0. First, what we are doing, temp is 0? No. So it goes in the loop. First temp mod 10 is calculated. That's temp mod 10, 345 mod 10, 345 divided by 10, remainder is 5. And that 5 is added to sum. So sum is 0, so that becomes 0 plus 5. That's good. And temp is divided by 10. So the last digit disappears. Temp compared again 0, 34 is not 0, right? Yeah, that's not 0. So temp mod 10 leaves 34 mod 10, 34 divided by 10 leaves a remainder of 4. So 4 is added to sum. Next, temp is temp mod 10, 34 becomes 34 by 10, 3. Temp is still not 0, so it goes and does sum plus temp mod 10, temp mod 10, 3 mod 10, 3 is a remainder 3 when divided by 10, so 3. And that's it. So for 345, the value which should be returned will be 5 plus 4 plus 3, which is 5 plus 4, 9 plus 3, 12. And that's our program. That's how this sum of digits program works. Until now, we looked at a few programs which shows how to use a if, how to use a for loop, how to use a while loop. These are a really good start for you to start understanding how programming is done and how programming logic is developed. So go ahead and try a few more programs of this kind. You only become a programmer by programming. So go ahead and try a lot more programs. Try to write these programs on your own. And if you're preparing for C interview, we have a complete C interview guide available. And if you're preparing for a C aptitude test, then we have C puzzles for interview as well. You can find the links to this in the description of this video. If you loved this video, then we are sure you'd love our other courses as well. We have more than 10 GitHub repositories with examples on C, Spring, Java, basic web application, Maven, Mockito. Whenever you are in need for examples, you can look these up. We have a number of courses created on ChalkStreet as well. You can search for in 28 minutes in chalkstreet.com, and there you go. Right now we have 3 different courses in here. I'm sure there will be a lot more courses and we have a lot of courses on C, Java, Spring, and a lot of Java related frameworks and web applications on Udemy as well. You might like some of the most watched videos on our YouTube channel. We have courses on design patterns, web applications, Maven, Spring, Eclipse, and web applications as well. Good luck with your learning. All the best for you. Until next time.